In this video, I'm going to be going over the derivatives of trigonometric functions. So I'm just going to list them out, and then for a few of them I'm going to explain why they are the way they are. So the derivative of sine x is cosine x. I'm just going to list them. The derivative of cosine x is negative sine x. The derivative of tangent is secant squared x. The derivative of secant is secant x times tangent of x. Cosecant is negative cosecant x times cotangent x. And then cotangent is negative cosecant squared x. So these are all of the derivatives for trig functions. It'd be best to memorize these since they do come up a lot in AP Calculus, and it'd just be helpful to know them all off the top of your head. But I'm going to explain why these four are the way they are. So we have f of x equals tangent of x. And I'm just going to write up here real quick the two fundamental ones. Okay, so we can separate tangent into sine over cosine. So we can use the quotient rule, and we know that so the quotient rule is the derivative of the top, which is cosine x, times the bottom minus the derivative of the bottom times the top, all over the bottom squared. And so we can simplify that down to cosine squared x plus, because this is a negative, sine squared x over cosine squared x. And we can refer back to our trigonometric properties. We know that cosine squared x plus sine squared x equals 1. So really, the top is just 1. And then 1 over cosine is just secant, so this will be secant squared x. And so that is the derivative of tangent. Now I'm going to go into the derivative of secant. And so we can separate this 1 over cosine. And so we again use the quotient rule. So the derivative of the top, which is 0, times the bottom. You can kind of just forget about that though. Minus the derivative of the bottom, negative sine x, times the top, which is 1, all over the bottom squared. And so that just becomes 0, and then this becomes positive, so it'd be sine, it'd be sine x over cosine squared x, which we can rewrite as sine x over cosine x times 1 over cosine x because this is squared. And then this just becomes tangent, and this becomes secant. So tangent x, secant x, and that is the derivative of secant. Now I'm going to do the derivative of cosecant. So we can break this up into 1 over sine. Then again use the quotient rule. So the derivative of the top, which is 0, times the bottom, minus the derivative of the bottom times the top, all over the bottom squared. That just becomes 0, and that becomes negative cosine x over sine squared x. And then again we can break this up to negative cosine x over sine x times 1 over sine x, because this is squared just like the other one. This becomes cotangent and this becomes cosecant. So negative cotangent times cosecant x. And now I'm going to do the last one, which is cotangent. We can break this up into cosine x over sine of x. So now we do the quotient rule. So the derivative of the top, negative sine x, times the bottom, sine x, minus the derivative of the bottom, cosine x, times the top, cosine x, all over the bottom squared, which is sine squared x. And so this will become negative sine squared x minus cosine squared x, all over sine squared x. And we can factor out a negative 1 here to make sine squared x add to cosine x, cosine squared x, to make it 1. Negative 1 sine squared x plus cosine squared x all over sine squared x. And then this just becomes 1. And so this will end up being negative 1 over sine squared x, which is negative cosecant squared x. And that's the derivative for cotangent x. Thank you for watching, and I hope this helped.